To start the next talk, which is Marco and Cornelius, who are talking about how to charge your electric car with the open source way. So over to you. Thanks.
Thanks a lot. Yeah, we want to show you about EV charging. It sounds easy, so charging a car shouldn't be too complicated. And is it really that easy? And let's dive into it. That's a really, really huge ecosystem, what kind of evolved over the 10 years. So even before, there have been a lot of cars. And it's from the car, the charging station, a lot of different cloud operations, there's a lot of protocols. I don't want to dive into all of that. We're just diving into that, say, car versus charger versus a bit of more. And yeah, let's digest that. What's all included in there? And you basically start with the charging station. There's a controller, let's say a Raspberry Pi. There's some power electronics, and there's a car connected. Data link and power link. So yeah, power. There could be different versions of that. AC, voltage is different in every region. Number of phases is different. The amps are different. You can also go DC. You can go inductive charging. So a lot of ways of transferring the power. On top of that, you also have a data link. There's a physical layer, how you can transfer that information between car and charger. And there's a, let's say, really dumb version where you just have a PWM signal, which is often used. But there's also way more smart stuff where you're exchanging kind of XML messages in a really, really weird format. And this is just an extract of the different protocols you have. And this is just one link. If you're extending that, wait 1 second. And last layer of complexity, just between car and chargers, is the plug. I mean, in Europe, we are kind of standardized to this Type 2 or Type 2 combo with DC pins. But there's another link from charging station to cloud. And also there, you have a lot of different protocols. Open Charge Point protocol is one which is often used, but some legacy stations are using something else or doing their own stuff. And also here, a big protocol stack. The fun fact is most stations have settled on this OCPP. So you're saying, hey, it's the internet, it's dominant, we're all saved. But there are so many different dialects, like everyone speaks the different versions of that protocol. At the end of the day, you have to really test each cloud with each charger, and it's a big nightmare. But it doesn't end there, so one cloud has to talk to another cloud to do roaming. So if you have a payment provider from company A and the charging station in front of you is from company B, how do they communicate with each other? Yeah, and then ideally, you just want to plug in your car and it charges, so you have to put a lot of public key infrastructure on top of that to get that running. Looks like a nightmare, and yet it's not running yet, and it should be there since 2014, really soon. And it's not yet out in a broad distribution. So next level, you maybe want to talk to humans, so you have maybe a display, maybe an RFID reader, and there's kind of no standards at all. Everyone is doing something different there. And yeah, then you have maybe other charging stations, left, right. You have electric grid where you want to drain power from. And also here, again, a lot of different ways how you want to communicate with your local solar stations, a lot of different protocols, and it's really nightmare. If you ask any electrician of, can I get a charging station which speaks to my solar and I just charging what's left over? You're barely able to buy that because nothing works together. And yeah, if we then go to the big electricity grid, it's even worse because they're just starting yet to get some way of exchanging information about electricity. So what's the current pricing? What's the future pricing? Can I get basically only pay the current stock market price for the energy and not something like an average? And can I maybe disable my charger if there's a local shortage of transmission? So even if the stock the exchange price for the electricity is really low, it could be there's a bottleneck in your local grid, in your street. So you could get paid for that if there would be a protocol to manage that. So in total, with a lot of links on the charging stations, there's too many standards, too many dialects, it's ever-growing, nothing really works. You have really pure user experience, and it's really, really expensive to build such charging stations, because of all that reasons. And in the end, I think it's not good for the goal of electrifying all cars and basically get rid of all carbon exhausts in the entire industry, what we have to do for saving the boiling planet. So how can we fix that? We could invent a new standard, right? One standard who fits it all. But then we're ending up in that situation, then we just added another standard to that nightmare. The other ones won't go away. So we think that won't work. We think you can do that by open source, but just basically implementing all the standards in one common library. Maybe you remember the browser wars. Nothing was compatible 10, 20 years ago, and you have to test every website against every browser. It wasn't fixed by improving HTML. It was fixed by getting less engines and doing them open source. And we're just a tiny puzzle piece in an even bigger ecosystem. We're part of the Linux Foundation Energy, which tries to build a software stack for the digitalization of a green electric grid. And there's so much more to it. And we just scratched on the car charging part, which will be big in the future, but again, it's only a tiny fraction of what we have to do. And let me hand over to Cornelius, so how we want to fix that.
Yeah, so let's have a look at what EVerest actually is and how we're trying to solve this mess and improve it. So we're basically writing a complete operating system for EV chargers that provides all the functionality needed for both the smart home use case, so basically for AC chargers at home, where you want to do solar charging and all that stuff, but also for commercial fast chargers that you find on the highway. So we're basically trying to implement everything that's between the car and the cloud. The EVerest stack runs on basically any tiny embedded Linux, and the aim is to support as many hardware configurations as possible. And it comes in a commercial-friendly license, so it's all Apache 2 licensed. And the whole idea is that it's not good for the ecosystem if everybody reinvents the wheel. That's the current situation. Everybody re-implements the same protocols. But what we want to do is provide an open source layer that just everybody can use to improve compatibility, and then all the charging manufacturers can focus basically all their energy on providing just a few unique features for their product on top of the open source stack. So how is EVerest built up on the inside? So it's a very modular architecture. It's kind of a microservice architecture where each module runs as a separate Linux process. And these modules can expose interfaces on an MQTT bus. And modules can also require interfaces from another module. And there's a config file to connect those. We will see that in a minute. And then modules can communicate. So one interesting topic is, we will see that later, how that helps, is that these modules also can run on different computers. Since it's MQTT, they can also communicate over the network with each other. And there's a whole framework around it, which we call the EVerest framework, that basically does all the MQTT abstraction and takes care of starting and stopping modules and stuff like that. So one central thing is the configuration file in EVerest. So it's basically a JSON file where you describe which modules to load, and it kind of represents the hardware. So the image is not meant to be readable. It's just showing like what modules are typically there. So the idea is, if you build a wall box, for example, with two outlets to charge two cars, you basically just load the charging modules twice, and then maybe you want cloud connectivity to a backend, so you load the OCPP module, and maybe you have some energy management, so you load some energy management modules, and then you basically configure your product. And this is super simple. There is even a graphical tool to do that now, so it's a web tool where you can configure the whole software stack. you can basically see on the left side all the available modules that are there. You can just drag and drop them, configure the individual modules, and also basically create that configuration file by drawing lines between the modules for the connection. So that's super simple, and then once you're done, you can basically hit run, and it will start EVerest, and you have a charging station up and running, configured for your hardware. What are the typical modules that are inside? So most important, of course, is kind of the charging core. So there's one module which we call the EVSE manager. That's essentially the central module that controls one charging port to one car. It also owns the charging session, so it basically knows when it starts, knows when it ends, it knows everything in between, like how many kilowatt hours have been charged and all that. And it also manages all the interaction between the different norms. So Marco briefly talked about this. So there's kind of a basic signaling, which is just a PWM signal on the control pilot wire. But then they found that it's not enough to just have a PWM signal. So they put an Ethernet link on top of that by using powerline Ethernet over the same wire, which means there's also the so-called high-level communication with ISO 15118 or DIN-spec, which is essentially a protocol based on XML, where you can talk with the car, and it gives you more details such as how many kilowatt hours are required by the car to fulfill its charging target, and how big is the battery, and there's a lot of more information that you can get out of that car while charging. And that stack is kind of a separate module, which you can load to support that, or you can just leave it out of the configuration, and then you have just a basic AC charger. For DC, you always need that, because DC is completely based on ISO and DIN-spec protocols. Underneath these charging core modules, there's a couple of modules which basically represent the hardware abstraction layer. We tried to make it super easy to port it to new hardware. There's basically just a few things needed. There's one module needed for the control pilot signal foo. Basically, that's all the PWM generation. You just need to write a small driver that outputs the PWM at the correct duty cycle and stuff like that. And then there is hardware abstraction for things like power meters, if you want to measure how much you charge, for RFID readers. Basically for the power line layer, there's also a slack driver. But if you use like commonly available hardware, there are good chances that there is already a hardware driver in EVerest for that. Looking at the other side, not so much to the car, but to the cloud for basically payment stuff, we provide an OCPP 1.6 JSON implementation. And we took a lot of work to actually make it standard compliant and not just our dialect of it. We verified this with as many commercial backends as possible, and also with the official protocol testing tool from the Open Charge Alliance, who supports the standard. And I think we're the only implementation of OCPP that actually supports all the optional profiles, even with smart charging and all the security extensions, which typically no one implements, even not in the commercial stuff. So I think we're the most complete, and also we are the only really working open source implementation of that. One of my favorites in EVerest is actually the energy management. So you can use the same mechanisms that we just showed for configuring the charging station, basically drawing these, like drag and dropping these modules and connecting them. This time not to represent the internals of the charging station, but you can also use it to basically represent the externals of the charging station, so the whole power distribution tree of the house. So on the left side, you see this, it's labeled fuse 40 amps, for example. That's kind of the grid connection point where the power enters, where the house is connected to the power grid. You can basically load a module for that. That's typically just a fuse, so EVerest needs to know what the fuse there is. But you can also connect like side modules to it, for example, a power meter, so that EVerest knows what the power consumption at the grid connection point is. And if you, for example, have a electricity contract that has variable prices for each hour, that's, at least in Germany, there are now 3 providers available for that, you can also feed that in. So EVerest knows in the end, okay, at that point, I'm getting power, it's that much, and it comes at that price. And from there, basically, you can model all your fuse power distribution tree of the house. And it can be basically any arbitrary tree. I just made some example here with the 16 amps fuse on top and 2 chargers that are also 16 amps each. So you can already see that you cannot operate both of them at full power at the same time. And on the right side, you see there are cars connected to these charging stations. And typically, every car has a different goal. So for example, the first one just needs to leave as soon as possible. So we want to charge as much as we can. The second one, for example, needs to leave 7 a.m. next morning and wants to charge as cheap as possible until then. And that's already relatively complex because you see on the bottom we also connected solar panels here in the energy tree. And it comes with a solar forecast for the next couple of hours. So if you want to leave 7 a.m. next morning, an optimal solution might be that you're charging, for example, this afternoon between 2 p.m. and 4 p.m. because you know that the sun will be shining and there will be excess power available. And maybe the remaining energy that your car needs will be charged in the night between 2 a.m. and 4 p.m. because there your price indications show it's going to be cheap. But since you know from the car how many kilowatt hours it needs, you can pre-plan that ahead and make sure that it's actually full at 7 a.m. in the morning. This, for example, is a use case that actually no charging stations currently really can do. And yeah, there are other charging goals, such as I only want to charge excess solar power that otherwise would be wasted, and I don't care when it actually is full. And there's already also cars that are connected to the charging stations that are already fully charged but still block one charging station. So once we have all that information available, we're basically running a global optimizer over that whole tree that makes sure that all the charging goals of the individual cars are fulfilled as good as possible, while at the same time all the restrictions from fuses are also met, and we will not blow any of the fuses at any time. And we can control this a lot faster than the fuses are, so we can make sure that actually that always works. The whole energy management gets a lot more interesting when the cars are able to charge bidirectionally, so that we can draw power from the cars back into the grid, because then you can do a whole lot more optimizations. For example, the one car that uses the excess solar energy but doesn't have a fixed time to leave can be discharged to charge the car on the top who needs to leave as soon as possible to fulfill that target, because we know that when that car is already gone, we can recharge the other one with the solar power again. So then the whole optimizer gets a lot more complicated. That part is actually under heavy development, and we'll have a small workshop on that tomorrow morning at 11 a.m. So feel free to drop by at our camp. Yeah. What else do we have? We have a small display app. So for all chargers that actually have a local display, there's a Flutter-based app that we will also basically port to Android and iOS in the future, but right now it's only for the local display. What's interesting as well, we have a complete software-in-the-loop simulation, so the hardware abstraction layer I was talking earlier about, for each of the hardware drivers, there's also a software simulation module available, so that basically you can run the whole EVerest stack just on your laptop without any charging station or a car. And you can also load a simulated car module that you can attach to those simulated charging station modules, and you can run full charging sessions, including ISO 15118 support, and basically develop EVerest and run simulations, and can do fully automatic testing, for example. Yeah. We do use a lot of Node-RED during development. Since it's based on MQTT, it's actually fairly easy to drop in Node-RED and build some development UIs to visualize something or add some buttons to do something in the meantime. So that's a very nice tool to use with EVerest. Yeah, and basically that's
it.
What EVerest was about.
Yeah, so and again, feel free to join us on GitHub and feel free to come to our camp. We're, let's say, here some meters, some meters north from here. We have a couple of cars. I think you can't miss it. We will do the energy management workshop tomorrow, and we're basically here the entire time. And we're also meeting once a week. We do all our development meetings publicly. Once a month, we have like a summary, what's new, what's going on. You can join. And yeah, if you have any questions, feel free to ask.
Do we have any questions at the moment? Well, I've got one. Is this going to lead to more affordable electric car chargers? As an owner myself.
I think it will lead to stuff better working and cheaper charging stations.
Okay.
Because at the moment, I don't know, the company's spending a lot of money on engineering again and again the same stuff. So they don't have to do it.
Yeah, okay, cool. Oh. Any other questions? Actually, out of interest, how many people here own an EV at the moment? Oh, a fair few. And how many of you will buy next MCH? Anyone planning to buy one before next MCH? Or you're all sticking to, I don't know, I don't want to think about how much diesel's going to cost by then.
Okay.
Anyway, brilliant. Thank you very much indeed.
Thank you.
Great.